Hi. Thanks a lot, everybody. Thanks for coming over to attend this webinar. So the title of the webinar today is How AWS Cloud Analytics Drives Audience Engagement and Revenue. Following is the agenda, which we will be covering during the course of the webinar today. We will initially start off by talking about some of the media workloads we address in the media space from the AWS side. We then go on to talking about the AWS architectures for specific to the big data workloads. We would then cover some use cases in the analytics recommendations workspaces. We would then we then talk about some of the partner solutions which are available. Interestingly, what we also have in the webinar today is partner speakers and customer speakers. We are glad that we are having our partner speaker, Mr. Pranam Chatterjee, who is the CEO at Blue Pie Technologies. Additionally, we also have our customer, ABP News, which is one of India's biggest news channels. And we have Mr. Ritesh Gondal, who's the head of technology there. And along with him would be Mr. Anuj Sharma, who's the lead in technology at ABP News. So on the screen here, we see the specific media workloads which we see in the M&E space right now. If we start from the left, we basically talk about content production. Now here in this, the solutions what we address are specifically around rendering, modeling, video editing on the cloud, broadcast signal acquisition. We then talk about content storage. We've got different flavors of storage, as we know, S3, infrequent access, and Glacier. We've got different mechanisms and means to fast ingest content into our storage. Again, this would depend upon the kind of content which gets ingested into storage. We also have partner solutions here ranging from digital asset management offering, media asset management offerings from a partner ecosystem. We then move on to the processing and management workload. This basically talks about encoding, transcoding, and packaging. We have two offerings from AWS here. The first one is for VOD kind of specific workloads, mainly for user-generated kind of content. This is a service of ours called Elastic Transcoding Service. The other service which we have in this area is Elemental. Now, AWS acquired Elemental a year back, and we've got services here to address workloads around encoding, packaging, transcoding, on-the-fly transcoding, live to VOD content creation, and so on. We then move into the content distribution space. We have close to around 63 points of present CloudFront POPs across the globe, and we specifically in the M&E space cater to requirements around live and VOD streaming. With our partner ecosystem, we also have solutions to address monetization requirements around live and VOD content, be it in terms of pre-rolls, mid-rolls, mid-roll ads, both for live as well as VOD use cases. We then talk about the media and analytics and the analytics workload, and this is the workload which we'll be specifically talking about today. Now some facts. These are basically the facts what we have seen in the with our customer base, be it from broadcasters, content aggregators, news channels. Some of the facts here mentioned, I'll just read from here. Netflix, over 75% of what people watch comes from recommended content. That's a great amount of conversion, right? 75% if we are able to cater to our audience base just from the set of content which we can pull over from our archive, depending upon what people are viewing or what they would like to view, is what Netflix is telling us. Nielsen, social media activity tweets drive higher broadcasting up to 48% of shows. Interesting. Google, 70% of variation in box office performance can be attributed to movie-related search volumes. That's really the reason why we're seeing some of our customers in the content production space, movie production space, trying to now take the digital strategy very, very seriously. If 70% of their business depends upon the success and then trying to promote it in the digital side of it, that's really the reason why we see all of our customers in this area very, very serious about it. So this basically is a slide which talks about the audience engagement signals. These are the interfaces by which the users tend to interact with the content. Two kinds of signals, transactional signals and behavioral signals. In the transactional signals, we talk about the interface of the consumer with regards to search, volume, search, listen, play, download, purchase, contact, support, subscribe, and then the behavioral side, once the consumer has interacted with the content, this talks about rating it, reviewing it, or any sort of commenting in the social channels, tagging it, and so on. So these are some of the data points on which the models are created. The models could be in the form of historical content, which could be the analytics, what exactly is going on, and then building up models to predict content around it. Following is a snap of the way we look at the analytics spectrum. We start from descriptive. This relates to what's really happening or has happened. Historical data. This goes to show us what kind of analytics we are trying to derive from people who are trying to interface with the websites or the content. How many people are viewing the content, from where are they viewing it, did they view the entire content, only a portion of the content, different kinds of devices. So this would be a part of the descriptive spectrum. Coming over to the predictive, in the predictive is then based upon statistical forecasts, based on machine learning mechanisms, which then go on to predict, basis the data which we have, the likelihood of people whom they've, say, watched a movie, then again within a specific set of users, based upon their analysis as to what's the best content to then provide to a new user who's aligned to a specific category. Or in other words, if I'm viewing a specific content in, say, a news page or a news article, then which are some of the other recommended stories which I should be recommending to the user. If I'm a user who's more aligned to viewing news content, then I'll be pushing news content to the same consumer and not pushing some other thing. So that's on the predictive side of it. And then prescriptive would be the business intelligence. Depending upon the descriptive and the predictive intelligence, then trying to see as to what's the best way in which the customer should project their content to their consumer base. I would also just like to mention that if there are any questions, please post them to us. We have our engineers on the forum here, so they will try our best to answer them to you. The next slide talks about the different kinds of topics which we will be talking today, mainly the analytics around content, which is the top content, the engagement, how much was the content really viewed, what was the tipping point, was there any buffering reported initially, what was the referral path. In the audience space, we then talk about when, where, who was the audience who came and viewed the content, was there any churn rates. We'll also show some dashboards there just to illustrate how a typical churn rate could look like, or a churn dashboard could look like from a partner ecosystem solution. In the operations part of it, basically it talks about what's the best way in terms of delivering content to a consumer, depending the data which the broadcasters would get about content delivery or performance of the content to the end user. All this then relates to the monetization aspect. When we are serving targeted content to the consumer base, when we have an idea as to what kind of content the consumer base would like to view, say in a specific age category or in any other category, then the CPMs which the broadcasters will be able to govern will be much better off than just giving generalistic ads. Following is a slide which breaks this down by specifics around the solutions available from AWS. Now on the left we see the audience engagement signals or the data, which is really the point from which we tend to work on. These are the audience engagement signals which we were talking of earlier. In the collection mode, we have our services like Kinesis, which serves to collect the data, put them into our storage, which is S3, then process it using our data processing capabilities and tools such as EMR, and then putting this forward to Amazon Redshift to derive useful, meaningful information of the data. We now move to the next slide. Just we'll talk about the specifics around collection and then process and then analyze. Here we see that once the data we have retrieved from either the player or the device logs, the same is then fed into Amazon Kinesis, through Amazon Kinesis to EMR, and then can be stored into S3. These are, as we move into the process part of it, now from Amazon S3 where the data can be ingested using Kinesis, Amazon EMR currently supports the following technologies and would work towards processing the data and then moving this over back into S3, which then feeds this into Amazon Redshift, and then using SQL we can have the intelligence derived and showcased on the analytics UI. We have a solution here with Amazon QuickSight. Additionally, we also have solutions like Tableau from our partner ecosystem. We now move into the machine learning and predictive space. Now in the center here you see the model which is based upon the signals which we get historically. The model is created, say, for content which is historical content, could be 2 months, 3 months, 6 months old content, and then deriving it and then making some kind of a model around it depending upon the specifics. The model is then subject to testing before it is put into production, and then useful, meaningful information can be recommended out of it in the test mode, and then once it's fully consolidated, once we see that there's a fair amount of recommendations which are coming correctly, we could then launch this into production. Why the cloud? In all this space we see that this is all based upon experimentation, hypothesis, testing. There could be scenarios wherein we have high amounts of scale which we need to test upon. So nothing better than the cloud which can offer adaptable and agile and flexible offerings. So that's really the reason why we see our customers trying to deploy analytics and recommendation solutions on the cloud. Because the kind of flexibility it offers, we can start to roll a project or test project depending upon the test which we need to do, and then terminate it whenever we need to do. So nothing better than doing this on the cloud. We now move into the use cases, the specific use cases or the use case scenarios which we see in the M&E market here today. The first one is broadcasters, publishers, everybody who's got content needs to analyze depending upon the kind of content, being it music content or articles related content, video content, and then trying to see what exactly is happening with that content, and then devising and designing content strategies around it, which could then lead to better revenues or better engagement to publishers and broadcasters. This can also have an impact in terms of understanding the consumers better, and which could then lead to profiling of the consumers. This also has impact in terms of selecting the best distribution network to select and then render the content using that specific distribution network. As we all know, CDNs are better in specific territories, so selecting the best CDN to provide the optimized performance is the key. So that's another use case which we see people utilizing this on. And then also predicting the audience churns. The next topic is related content. Now here we would like to talk about our customer example, which is Punjab Kesari. Punjab Kesari is a leading newspaper publisher based in North India. The slide which you see over here is an illustration of a page, a consumer reading a specific article, and then on the right hand side you see related content. Related content is the content which is similar to the content which the consumer is reading. So what happened after the implementation of the related content widget, the following business impact the customer was able to see. Within a month itself, there was a substantial 20% increase in the traffic level of the customer. 45% of the story-based traffic came from related content widget. The bounce rates reduced from a pretty high 63% to 53%, so there was a reduction of almost like 10%. Pages per session increased, and average duration per session also increased to a certain extent. This all led to increase in the number of page views of the customer. So eventually the traffic on the customer's domain increased, the engagement with the consumers increased, and therefore the monetization associated with the content also increased. So that was the business impact. We now see an illustration of a cohort for a session duration per user before implementation of this project, which they call as the big data project, and after the big data project. And we see here that the session durations per user actually increased after the implementation of the related content widget. Another benefit which they saw was the retention rate also increased. So if you see the graph here in the row for the cohort in the June month, we see that if 100% of users were there in the month of June, then the month of August, without the big data implementation, the retention rate reduced to 3.73% from 100% in June. And in the month, and the next one, which is the July one, shows that the retention rate after the big data project was implemented, the retention rate increased from 3.73% to 9.16%. So a considerable amount of increase there. We now move on to the video analytics space. Now, we as such from AWS provide the building blocks to provide a comprehensive video analytics dashboard using our partner ecosystem. On the slide here, you see the different kinds of parameters which can be analyzed and are shown as examples here. These could be related to user acquisition and churn, the content performance, monetization and revenue, cohort analysis, and subscriber life cycle. The dashboard here clearly illustrates, and this is just an example which we are showcasing here. So say for a specific duration of time, say for last month, for an OTT broadcaster who's got lots of content and who've got subscribed viewers, they had a 4% increase in the subscriber base. The payments associated with the subscriber base also increased, which is shown here. And then we can go into the specifics of it, say for a specific duration, could be a day, a month, a week, to get further insights into it. We get details related to acquisitions, churns, how many are active users right now, how many people are right now viewing the content in terms of the video content or the website content, the app content, and then getting further analytics and details about it, around it. The next slide shows a dashboard specific to streaming customers. So for example, if there's a video customer who does both live and VOD streaming, the dashboard here would show for a specific duration how many live concurrent viewers are there on the page, on the website, on Roku devices, on iOS, Android, Apple TV, Fire TV, and the likes. And this could be, again, with respect to a specific duration. The duration can be increased or decreased depending upon what we are really looking to validate and check. Video engagement is the next one. Again, how did the content perform on different devices, on different browsers, on different operating systems? There's also another analytic which is pretty popular amongst broadcasters, and I'm sure some of you there are. Depending, so that's basically relating to if it's a 10-minute video, how did the content really perform? Did people tip off at the first minute, third minute, 10th minute, to further get details on the content? So this could then be used to further devise strategies around the kind of content which needs to be further produced for specific kind of devices, locations, and other such factors. This is an illustration on the churn rate, how many people churned during a specific time. This is an illustration on the acquisition. And now we move into in the recommendation space. What I'll do here is that I will just pass the deck on to a partner who will also walk us through the recommendations and then talk about the specific use case here.
Thanks, Deepak. So let me first of all take a few seconds to introduce my organization. So we have been working with AWS as a partner for about 4 years, focused primarily on the media segment. And we have a full suite of turnkey solutions for the media and entertainment industry. It includes a CMS, a digital asset management system, mobile apps, and analytics and recommendation engines. So starting from the ability to create content, distribute content using mobility and on web, and then analyzing the distribution and then optimizing the delivery to different mediums. The entire suite end-to-end lifecycle is covered by our offerings. I will start with the CMS pieces. So what differentiates what we have on the content management system perspective is essentially a serverless scalable architecture. So what happens in the news industry specifically is that a lot of traffic is unpredictable. So some big news item breaks, it goes viral for a few seconds, and then a lot of traffic essentially comes in within that specific duration, short duration. So scaling a new site specifically is extremely difficult because there's no way to predict what kind of virality specific news items will see. Now what we have essentially is a serverless architecture wherein the content is distributed onto the S3 storage that's available as part of Amazon. So the editors, while they work on the CMS, use a proper CMS, but the distribution of the content is driven by a serverless scalable architecture. And what that allows us to do is handle peaks absolutely seamlessly. Now, because of this, what also ends up happening is that the system auto-scales, right? So the system has this ability to scale down when there is no load, maybe at the middle of the night, and when a specific story starts trending, it automatically can scale up. And this then leads to a significant reduction in the cost from a traditional CMS perspective. And it's built on top of WordPress, so all the capabilities that WordPress brings to the table are available, but at the same time there's a huge amount of engineering that has gone on to make this secure, robust, and scalable. The platform that we have also supports multiple different languages. We run it on sites which have 300 million plus page views a month, and some of the leading organizations, including ABP, and Ritesh will speak right after me, they actually use this platform to service their content. Now, the content that we deliver via the serverless architecture is also made available via REST APIs, and in a JSON structure can be consumed by different medium like mobile apps, and we have different versions for native versions for both Android and iOS. Um, Now what I'll do is I'll quickly move on to the analytics piece, because that's where the whole focus of this specific webinar is. And we have a product tailored towards media analytics, and it allows you to get very detailed, in-depth visibility into the performance of your site, of the distribution of the content, and as well as editorial content. This is a standalone product, so though it is very well integrated seamlessly with our CMS offerings and our mobile platforms, you can use this system via the open API that we have available and integrate any sort of CMS or any third-party applications that you might be using. So it definitely doesn't mandate that you use the full suite. You can use the analytics and the recommendation product separately. What does it consist of? So it essentially, like any other analytics product, has some dashboards. The dashboards are real-time. Given the capabilities that we have leveraged within AWS, what ends up happening is we have at the most a 4 to 6 second latency of action happening on the website and us capturing it via clickstream and surfacing it onto the web. And in the news world, the most important aspect is how quickly can you deliver analytics, right? Because the ability to react to what's happening right now is super critical. So the other cool piece that we have on this analytics piece is the fact that we track end user behavior. So everything that a user ends up doing on the site once since the time that they land is tracked. We cannot identify the user due to privacy reasons, but we know what actions has the user performed. And this allows us to build some interesting personalization capabilities wherein you can use this information to push specific targeted notifications on the mobile devices so that they get only information that is relevant to them and at a time of the day which actually makes sense. We also have some predictive analytics and some data science algorithms built into the system which uses all of this personalized data to recommend specific stories that a user would find useful. And it's available by an API. It's multilingual, so we are running it on probably 8 different languages right now for different news agencies. And it's a hybrid algorithm, so it's a custom homegrown algorithm which leverages some of the observations that we have seen in the new industry over a period of time. Not only does it use personalization based on user behavior, in the sense what the user has done in the past influences what he gets recommended, but it also uses capabilities like what is the freshness of an article, what is the popularity of an article, then is there a specific news that is trending right now, is that something that needs to get bubbled up as part of the recommendation. And all of these different algorithms then are combined with different weightages to provide a recommendation that would be suitable for a specific language, for a specific content. And as you would imagine, any news story has a very short life typically. So unless and until it's a magazine where the content has inherent value which would live on for a long time, most of the news sites actually run on breaking news and news which probably lives for about 30 minutes to an hour. So there's a lot of engineering effort that has gone on to make this entire recommendation engine real time, in the sense the moment you land on a specific page, there's a content based recommendation that takes place which takes into consideration what kind of content you're looking at, and then runs a similarity algorithm real time to recommend content similar to what you are watching right now. The kind of technologies that we use here, obviously some of these has been touched by Deepak. Kinesis, Elasticache, Elasticsearch. Let me quickly switch over to the demo and show you a few screens around and explain how the system actually works. So here's a dashboard. Now, so the dashboard that we have here, so this site that you see actually is running on 6 different sites, 6 different languages, and you have a dashboard which is actually showing the latest stories right now. And this is a real-time view. So as stories keep changing, the data refreshes automatically. And there are 3 primary metrics that we track. One is the number of page views, so how many times a page has been specifically seen, the number of unique users, and the amount of total time that has been spent on the page. Now this information is 30 minutes by default in this section. On the right hand side we have a comparison of what happened yesterday and the comparison of that with today, and as you can see there's a significant peak that happened yesterday at the middle of the night which didn't occur here today. And there are obviously the most important metrics around what browsers people are coming from, what are the different sources, different cities, and again the same 3 metrics in terms of page views, users, and time spent. Let me quickly show you a dashboard that we have which shows an aggregate of all the information across the 6 different sites, and it's something that you can actually project on a monitor, and because the system integrates with the CMS, you have intelligent information about the performance of authors and editors on the site, and you get a cross-language visibility, and there's some real-time video analytics as well, which gives you visibility into how on-demand as well as live TV is performing. And the last piece that I would like to show you is we have this cool predictive algorithm which actually predicts which stories are going to trend fairly quickly. So if, for example, you can see a story which got predicted that will start trending about 2:13 p.m. and by about it started probably 20 minutes down the line, it really started trending. Now what happens with this is the marketing department of the organization, the social media folks, can actually focus on the stories that are going to trend rather than dissipating their energies on stories which may or may not make it. Right? This uses some data science algorithms, including time series analytics, to pattern the stories out and then determine which stories are actually going to trend. So that's pretty much all I have. I will transition it over to Deepak, and thank you for listening in.
Thank you very much, Pranam. We now have Mr. Ritesh Kundal, who's the Chief Head of Technology at ABP News. Over to Ritesh.
Hello everyone, I am Ritesh. This side I am the technology head for ABP Live. ABP News Network it was previously known as Star News. We are one of the largest news network in India, and we provide news in 5 different Indian languages: Hindi, Punjabi, Marathi, Bengali, and Gujarati. And together we have a reach of almost 48 million users weekly. ABP Live is a digital initiative by ABP News. We provide news in 5 languages. Along with that, we also provide entertainment portal and a cricket portal. We have over 300 million views a month, and we do approximately 40 million video views a month. We also have our mobile app available over iOS, Android, and Windows. ABP, we've developed our own OTT video platform, which we use to manage, publish, measure, monetize video content over web and mobile. The entire platform has been deployed over AWS services, and for OTT platform we use EC2, S3, Elastic Transcoding, and Elasticsearch from AWS. I'll now present you few screenshots from our platform. This is our dashboard, which has been developed by the in-house ABP technology engineering team. This here we show all the latest video which have been uploaded by the editors, and we have a very interesting way of depicting what all videos have been shared on social network as well as on our site. Next, this is the general video editing, metadata editing screen where editors can edit their content. We can have custom metadata sent to different social platforms. We also have a concept of making playlists wherein we can show custom videos on custom pages. We also use this playlist for user recommendation. Whatever content a user might want to consume, we serve playlists according to their preferences. This is a broader view of the entire OTT platform which has been deployed over AWS. I will hand over the, this to my colleague Anuj, who is the technical lead in ABP News. He'll take you through in brief how we have deployed the AWS, video platform over AWS.
Hello everyone, this is Anuj. So as a technology team here, we are taking care of everything which serves our video CMS and the different aspects which we are using in-house, we've built in-house. The diagram on the screen is a small overview diagram how videos are being transcoded and used by different websites. So just a small flow, if you can see that the user or the admin or the editor basically uploads a video on the EC2 instance. The video is then transferred to the S3 bucket. Then the S3 bucket along with the request is given to the transcoder, which transcodes the video and gives us the output on the S3 bucket only. And a CDN is mapped to this bucket, which is used for different web users, as in the players or the mobile apps. So the videos is streamed through this particular CDN in the S3 bucket. So these are all the components from Amazon which we are using, and this is all about the video CMS. So the technologies which are using, the parts of the AWS we are using is the elastic transcoder and one second. Yeah, elastic transcoder along with the EC2, S3 and CDN. So moving on to the video analytics part, this is also built. I'll hand over this control to the Ritesh. He'll tell about it.
So now moving on to the video analytics part, we did a lot of research in the market, and we tried to figure out the best solutions available for analytics, especially in the video category. Either some of the solutions were not catering to our requirement. We wanted to measure the quality of service. We also wanted to measure our reach among different devices. So a holistic solution was not available to us, or it was quite expensive to deploy such a solution. So we finally decided to go ahead with a custom development and in-house solution developed by our technology team for video analytics. And essentially we wanted to measure the reach, usage, quality of service, which is very important to us across devices. And while doing our research, we figured out that deploying the solution over AWS will be a much easier option, and we would have a complete array of services which will help us do real-time analytics as well as content recommendation and measure the quality of service for our video. So as of now in the video analytics, we are using the API gateway to capture data, Kinesis for data transmission and real-time analytics, S3 to store the data, and Redshift and EMR to analyze the data. These are some of the screenshots from our analytics platform. where we can select different matrices for live video, on-demand video, and we can have results accordingly. This is our dashboard where we get the real-time usage on our video content for live and on-demand, and also the actual numbers on any particular video which might be trending right now. I'll again hand over the technical explanation to our engineer Anuj Sharma. He'll take you through how we were able to deploy the entire analytics solution over AWS.
Okay, so the block diagram is for the video analytics, which is again built in-house using AWS components. So API gateway is being used for storing all the data. So which is being imported to the Kinesis Firehose with the destination as Redshift and an intermediate bucket where all the data is first of all dumped and then moved to Redshift. We have our EC2 instance which initiates the EMR instance, EMR engine basically, which works on the S3 bucket to aggregate all the data and store again onto S3 bucket, which is then later pushed to Redshift tables. And these Redshift tables are again source for the analytics interfaces, which is our integrated in our dashboard. So I'll quickly move on to the video analytics demo. So I'll hand over to Ritesh. He'll show up the demo of the analytics.
So for video analytics, as I told you, we are using it to measure the quality of service, which is important whether video is playing over some device or not, what is the lag in which video is taking to play, are there any errors, are user clicking on our ads. So we do a whole range of services, we measure a whole range of matrices with our video analytics. Why we deployed over AWS? One, scalability. As news is a very dynamic environment, we on a regular day, if you're getting a particular amount of traffic, that traffic might increase at least 50 times in like next second. That is the dynamics of a news environment, and that's why we wanted a scalable solution or infrastructure which was provided by AWS. Elasticity, again, with the kind of peaks we get, we need an elastic kind of a solution where we do not lose data. Real-time encoding, the entire video is done real-time over AWS, and it was quite easy to deploy the entire solution, and that's why we chose AWS. I'll quickly take you to the demo screens. So this is our dashboard. We can select whether we want to show video or video on demand or live TV matrices. We can select any kind of matrices which we want to measure, and we can deselect also. And we can also select whether we want to show URLs or we want to show title in the yeah. So the entire data is right now coming from Redshift. So there are billions of records which might be we might be tracking on daily basis, and from there we get this data on real-time basis. So this is a small snapshot. We can switch between channels. We can change our date, and again the entire data is coming via AWS Redshift. We also track device-specific data. So not just web, we are also tracking our mobile applications which are deployed over AWS, and we get the real-time usage of our content from our analytics.
Thank you, Ritesh and Anuj, for the detailed information there. So with that, we basically come to the end of this webinar. Thanks a lot, guys, for being available during the course of this session. And please send us your queries if there are any further requirements or any discussions which you need to do with us. Do send them over to us. Thank you, guys. Thank you very much.